Yeah, so factoring is critical to this. If you can factor polynomials, you know how to do like a GCF and all that, you'd be pretty good with this. So let's get right into it. So what we're doing is we're simplifying. Rational expressions is a big broad thing. Like we can add them, subtract them, multiply them, divide them. It's all sorts of things. But today we're just going to be given one fraction and asked to reduce it. So, you know, not like fourth grade fractions, but high school fractions. So got a bunch of examples. That's a 5, by the way. I apologize for that ugly 5. So the first thing we got to get out of the way is that you're not allowed to cancel things when they're parts of addition and subtraction problems. You're probably going to hear me say something just like that at least 50 times in the next 2 weeks. So save us both the headache, and don't try to cancel things when they're parts of plus or minus. So the only things that can be canceled are things that are called factors, and there are no factors in this problem right now. The top is a big subtraction addition problem. The bottom is a big subtraction addition problem. So what we're going to do is use something that turns adding and subtracting into multiplication, and that's called factoring. That's always been what its purpose was. And so I'm going to take the top of this and factor it down to make multiplicative parts instead of additive parts. What does the top factor down into? I'm going to just, yeah, that's okay, man. It's going to get better from here. X minus 7 times x plus 5. So now you have two factors on the top. The things in parentheses become what we call factors, and they become cancelable items. And then I'm going to factor the bottom into what? Right. So you can see already like what I'm talking about. If factoring is rough, then, well, I am sorry in advance. You're going to be miserable for a little while here. And by a little while, I mean like almost the whole rest of the year. So make sure you're really good at factoring. Now, what we're going to do is say, okay, now that it's like something times something over something times something, I can now eliminate that entire factor with that entire factor. And the reason I can get away with it again is because they're multiplicative pieces called factors. Factors can be canceled, plus and minus things cannot. So our final answer to this problem is x minus 7 over x minus 6. And I'm sorry to ask this, but I am going to until I'm sure you know the right answer. Why can I not cancel those x's out? Because they're part of subtraction problems. Thank you. You got the memo. Make sure you get on board with this. If I am part of an addition or a subtraction problem, I cannot be cherry picked out and reduced with something else. Okay. I've got to be an entire multiplicative factor. Someone asked me earlier why it doesn't work. Like I remember somewhere in the lecture, we got something, it was like 6 plus x over x. And someone asked the question second hour, like, why can't I cancel those x's out? And I thought I came up with a pretty good explanation. So I thought I would show you why you can't cancel them out. So let's say we did like 6 plus, I don't know. I should have picked a different number here. Let me pick an easier number to work with than the 6. How about like 4 plus 4 divided by 4. So right now, if I and what I'm trying to do right now is show you something that will maybe stick with you so you never want to cancel things out when it's illegal. Right now, if I did this math problem, and you all know this, like you know this very, very well. What is 4 plus 4 on the top, right? And what's 8 divided by 4? So you know the answer to this problem is 2. You're not pretty sure, like you know. But if I could legally cancel things out, if someone could give me something like 4 plus 4 divided by 4, and then I could go, ooh, look, I'm going to cancel those 4s, what would the answer be? 4. You know, you could come up with a lot of examples of why it just does not work to convince yourself of why the math gods would come up with this such a cruel rule, like something is so tempting to cancel, but then I'm told that I can't do it. So it's going to be probably one of the hardest things to overcome is the temptation is going to be there when you see things on the top and the bottom. But if they're parts of pluses or minuses, don't touch. They're off limits. Okay. All right, let's go again. Round two, x squared minus 4 over x squared plus 3x minus 10. Factor Fest 2024, eh? What's the top factor down into? What is the top? That has a name, you remember? Good job, bud. It's a difference of squares. It factors into x plus 2 times x minus 2. So what we've done is we've taken the top, which used to be a subtraction problem, and we've turned it into a multiplication problem. That is the reason why factoring even exists. Then the bottom is currently an addition subtraction problem. I want it to turn multiplication. So what does it factor down into? Good job. So again, just like the last problem, I'm looking now for entire multiplicative pieces that are identical. And this x minus 2 is an entire factor that is identical to this bottom x minus 2, leaving us with the final answer of x plus 2 over x plus 5. Done. It's hard. It's a tough pill to swallow the first day or so where you just so badly want to cross off those x's, but you just can't do it. Good so far? Easy peasy? All right, let's keep going. So I'm going to start branching you out a little bit and forcing you to think of factoring as something other than just two sets of parentheses, right? Two numbers that multiply to make this and add to make this. It's not what factoring always means. So what does the top mean to us? Right. Someone says factor the top. I don't go and draw two sets of parentheses and go, what do I do now? I recognize this from my experience that I have to pull out a GCF. So on the top, I'm going to pull out X. And what's that going to leave me with? Nice, X plus 3. And then the bottom is a pretty standard, just quadratic trinomial. What does it factor down into? Beautiful. So again, I see factors now. I don't see pluses and minuses. I see something times something over something times something. Those somethings now are in play. It's open season on them. Any something in the top that's the same as one in the bottom can be killed off. And so this x plus 3 and this x plus 3 can be destroyed entirely. What would the final answer be here? Good job. And again, as much as you might want to kill those x's, you can't. All right. Any questions on that one? All right. What do we do on the top? So the top has a common factor of x cubed. What does that leave behind? Just x plus 10, right? And then what about the bottom? What can I do on the bottom? Pull out an x squared, and what does that leave behind? Good. So I have a bunch of factors, and the good news now is because they're factors, I can hunt them, and now I can take things out. How many x's can go? Right. If you think about, like, if I were to write this out, x to the third on top is x times x times x, and x squared on bottom is x times x. And so math is pretty easy when you let it be. These two x's on top can kill these two x's on bottom. You don't need to draw it all out like that. Like, it's pretty intuitive that you're going to have a leftover one and it's going to be on the top because that's where there were more. And so we're left with a final answer of x times x plus 10 over x plus 5. And I will say it again and again and again and again and again, that it's hard to resist urges. It's hard to accept the fact that with all those god dang x's in there, that not one of them can cancel, but it can't. And the reason why is this x on bottom is like, you leave me out of all your little shenanigans. I am part of an addition problem here. I am not yours to cancel. Now, if you can make another x plus 5 upstairs, we'll travel together and destroy out. But on their own, nope, that's the final answer. Good so far still? There's tons of examples today, okay? Next one. I tried to cover everything, and then, like I said, in a couple examples, I'm going to start adding in the questions that they had second hour so that hopefully I can kind of get in the way of any misconceptions you might have so that you can fly through your homework. Top is pretty standard fare, huh? What does it factor down into? Right. Just a nice classic quadratic trinomial. What is the bottom? Yeah, so we should be thinking for anyone who's a little bit confused, maybe this is where our GCF flag goes up. We recognize it as not a normal factoring kind of thing. It's a GCFer. So I'm going to pull out a 2x and a squared. And what does that leave behind? Careful, we pulled out a 2, don't forget. So it's x plus 8. And it just very nicely happens in this case that by doing that GCF, we expose something that we never in a million years would have seen before. But then we're like, hey, hot dog, look at this x plus 8 up here. I made you a clone downstairs. You guys can now go away. It's what reducing fractions is all about, is eliminating common factors. Even back in fourth grade, that's all it was. So we wind up with a final answer of x plus 3 over 2x squared. Again, both of the guys on top are like, leave me out of this, right? X and 3 are like, hey, we're parts of something here. You don't pick him, you don't pick him. You can take us together, but not individually. And then I have one more before the second hour questions start. And the reason I wanted to put this example into your lecture was to show you that something can happen that might make you think you're doing something wrong. What's the top? Right. So again, GCF flag goes up. I recognize it as one of those kind of weird ones. So I pull 2 out, I pull x out, and that leaves x plus 8. And that leaves me kind of yearning and hoping that maybe somewhere on the bottom I can unveil a 2 or an x or an x plus 8. But you probably already know where this is headed. The bottom is a difference of squares. What does it factor down into? So the purpose of this example was to show you that some expressions, I'm sorry, they're literally not even doable. Like, someone says here, reduce this fraction, and then you're like, is this a trick question? Like, it's already reduced, and that can happen in these problems. So there's no meat on this bone at all. No one can cancel anyone else. There are 5 factors up on the board. There's a 2, an x plus 8, an x plus 6, and none of them are the same. None of them can reduce. So just be aware that if this were the case, you could type in your answer as this, or since you did the work already to factor it down, you could type it in like this. They're one and the same. No harm either way. So that was where I ended the lecture 4 or 5 hours ago. And then I got just inundated with questions. So I figured let's knock these out, take about 7 or 8 more minutes, and then you'll still have some questions. And obviously I'm going to go through them with you. But these are the ones they asked about. So I was just going to leave them in the recording, but what the heck. So, I mean, from earlier. Every one of these that they asked about, I remember had a purpose. Like I go, oh, I should have said this or I should have said that. So that's kind of the impetus for wanting to do them with you. The thing about this one is it's already factored. You would agree. So what are we looking at here for reducing this down? You can. And so the thing about the bottom is if you think about this 12x right down here in the bottom, you would agree, I know you would, that saying 12x is no different than saying 4x times 3, correct? So if I identify this 12x, but I identify it as a 4x and a times 3, then it becomes pretty apparent that this entire 4x and this entire 4x, because they're multiplicative, can kill each other off. What does that leave on top? Just a 1, right? We like to say nothing, but we don't do that anymore. We know that there has to be a 1 Otherwise, the fraction falls apart. So it's 1 over 3 times x minus 8. So that can happen. You can void the entire top of the fraction and be left with nothing. So that's when you put your 1. By the way, this chapter, this unit won't get hard until we get to addition and subtraction. If you feel like you're kind of vibing with this today, it's not going to get much worse. It gets harder on Monday a little bit because I start making you pull out negatives to flip things backwards, but yeah, not that big a deal. So what about this one? On the bottom? Okay, good. So this one, I remember when someone asked about this question earlier, we talk about the GCF. And what is the GCF of the bottom? It is 12x squared. But I want you, if you're still listening and alert and stuff, you should think about that, despite all my lectures about GCF, this is one time when it would actually be okay to just pull out a CF. So I'm going to do something here that I've never purposely done with you before. But rather than pull out, I'm going to do what Cooper said. Rather than pull out the entire 12x squared, I'm only going to pull out 3x squared. And I probably don't have to tell you why. But that's one time when you can kind of think outside the box a little bit and say, by not taking the whole thing out, I'll actually save myself a little bit of stress later. I just want it to match the top. And so if I pull 3x squared out, what does that leave in parentheses on the bottom? Yeah, good math. So again, you see there's still meat on this bone. I'm going to underline it for you. This is not fully GCF'd, but that wasn't the point of this. Like to make the progress that we can make. The top says, you're not getting anything else out of me. You can get 3x squared out of me, but I got nothing else to give. And so by pulling out just enough, then I get to my final answer, which is, again, effectively nothing, 1 over 4x minus 16. Still would have worked if you GCF the bottom. You just honestly, it would be at the end a little bit more difficult because then you have to re-divide, kind of refactor. This question, I remember, I'll tell you what it's all about here in a second. And then after this, I got a couple more. And then the last 3, I could probably just explain it to you with just one example. I just want to show you a shortcut you can use sometimes. There's no shortcut on a problem like this. No way. So what is the top factor in 2? Good. And I'm going to write it out as x plus 8 times x plus 8, just so that I can have the conversation with you that needs to be had. What is the bottom factor down into? Good. The question that I got earlier was, what do I do when there's 2 of the same? And my answer was, well, you just pick one of them and destroy it. So sometimes I think it might be normal for a person to think that this 1x plus 8 can like laser beam knock out both of the ones on top. But you understand that when you reduce, you are destroying yourself in the process of reducing with something else, right? So if this x plus 8 says like YOLO, I'm going in, you only take out one of the ones on top. Okay. And it doesn't matter which one, obviously, like you just pick one, who cares? But you cannot destroy 2 copies of something with only 1 copy. So if that comes up, then now you know. I don't think that one was one more and then the shortcut way. Just hanging in there. Doing all right. Said it back in September and August and October, and I'll say it again. A good factor can just look and know right away. It's one of those, this is what I do. It's one of those, this is what I do. What is the top? It is a difference of squares. So immediately I go into that kind of robotic sort of thing where I know it's a plus and a minus, x plus 7, x minus 7. The bottom is really the interesting one with this. What's going on with the dang bottom here? What is that little booger? Right. So I have some options. Like I could pull out a 2, and that would leave x, excuse me, I'm sorry, 3x plus 41, 3x plus 21. Or I could pull out a 3, which would leave a 2x plus 14. Or I could pull out a 6, which would leave an x plus 7. Which one do we, now this far into the lesson, which one do we understand we really have to pick? The one with the 6. And it's not because I'm out of GCF mindset now. I'm pulling out enough CF to serve a purpose. But I understand that I can't unveil a match for one of these two idiots unless I pull out and make that happen. So by writing the bottom a very specific way, by pulling out a whole 6, then I expose another x plus 7, right? So you do have options sometimes. Just make sure you choose options that will, if possible, lead to progress. So that one winds up being x minus 7/6. All right, last thing I wanted to show you is that sometimes there's this doesn't work with most problems, but certain flavors of problems have a little bit of a shortcut. So this was the first one that came to mind earlier today. This one popped up on the board, and I wasn't really sure if I even wanted to explain it. And then I explained it, and I was like, "Oh, that's easy. These guys are good at math." So if I had you do this problem the same way as we've done all the others, you would leave the bottom the way it is, and you would factor some stuff out of the top, right? What I'm about to show you is technically the same, but it saves a little bit of time. This only works in problems when every term in the problem agrees to play nice. What can this, and this all be divided by? 8x. You can do that. It's no different than factoring it out of both places and then reducing it down later. But as many terms as there are, every one of them out there agrees. Like I can give 8x, I can give 8x, I can give 8. If everyone is on board and you divide them all, you can sometimes shortcut the daylights out of these problems. What's this first one if I divide it by 8x? It becomes a 4x. Very good. What's this second one over here if I divide it by 4 or by 8x, excuse me, minus 20. And on the bottom, what's this 8x if I divide it by 8x? So my answer is just 4x minus 20. I thought I would show you that. Would you like another example of that, or does that make sense? Good. So watch out for those. It's usually going to be those triangular problems with 2 on top, 1 on bottom, or 1 on top, 2 on bottom. Those triangular ones are usually where you can do the GCF like division shortcut. Don't try that on other ones though, unless you're sure. So I'll leave the recording going again if you have more questions, but it's on Delta Math, and that's, I think I covered it all, but you never know. You never know. I tried.